Plant Ecosystem, MECH2502 proposal by Kyle, Jasvini, Crabtree, and Mohammed. The objective of the proposed measurement system. So the proposed measurement system is used to water a plant. Through the use of various sensors, we can monitor the health of our plant. Sensors such as a moisture sensor uses voltage to detect the moisture in the soil. A photoresistor, which uses voltage to measure and detect how much light the plant is getting. An active buzzer, which buzzes approximately 2 to 3 seconds before the plant begins getting watered as a warning. A temperature sensor, which senses the ambient environmental temperature. The humidity sensor, which uses voltage to detect the surrounding environment's humidity. A step motor, which is used to tilt the blinds to a desired angle to allow light onto the plant. A pump, which uses a reservoir to allow water to be pumped into the pot of the plant. A MOSFET, which is an electronic switch that controls the pump. And a 7-segment display, which is used to display the data collected from the temperature and humidity sensor.
The sensing mechanisms of the sensors we're using. So the moisture sensor is a plastic bar with metal contacts on one face to sense the moisture levels when in contact with a wet surface. These moisture levels will be converted to voltage to allow us to manipulate the values when needed. The temperature sensor, so unlike a thermocouple, the one we're using uses the property of diodes. As the diode changes temperature, the voltage changes with it at the same rate. The sensor measures the small change and outputs an analog voltage between 0 and 1.75 volts DC based on the difference in temperature. And the humidity sensor, which is also a part of the temperature sensor that we're using, detects the changes that alter electrical currents or temperature in the air. A capacitive humidity sensor measures relative humidity by placing a thin strip of metal oxide between the two electrodes. The metal oxide's electrical capacity changes with the atmosphere's relative humidity. And finally, a photoresistor, which we'll be using, is a passive component that decreases resistance with respect to receiving light.
Now moving on to the building blocks of the envisioned system, which are one moisture sensor to measure the moisture levels of the soil, one MOSFET switch that controls the activation of the water pump, one water pump to get the moisture level through the MOSFET and pump water if the moisture level is not sufficient, one buzzer to indicate when water is being pumped, one photoresistor to get the light levels on the plant, one step motor to open blinds if the light levels sensed by the photoresistor are not sufficient for optimal plant growth, one temperature sensor, and one humidity sensor to measure the ambient temperature and humidity levels in close proximity to the plant. And if the temperature is lower than what it is desired, the step motor will activate the blinds to allow more sunlight to enter the room.
As for the potential applications in research and industry, our idea can be applied into different fields. For example, it can be used in greenhouses to make monitoring and maintaining the plants more efficient. It can also be used to automate agricultural processes. And that concludes our presentation. Thank you for watching.